Conditions for special parallelograms, section 6.5. So we are continuing on with our 3 special parallelograms. Who remembers the 3 special parallelograms there are? There are rhombuses or rhombi. Then we have rectangles and we have squares. Nice job. Those 3 special parallelograms we will be talking about today. The first ones here is how to determine whether a parallelogram is a rectangle. Now, these only are true if you know the shape is a parallelogram first. Okay, you have to know the shape's a parallelogram first, and then these different conditions meet the special requirements. So, for example, if one angle is a right angle, then it would be a rectangle. So if you look there, I know it's a parallelogram. Okay, I know it's a parallelogram. If it's a right angle, then it has to be a rectangle. If the diagonals are congruent, then the parallelogram is a rectangle. Okay, so if my diagonals are the same, then it is a parallelogram. Then it is a rectangle. If one pair of consecutive sides are congruent. Now, there's been some discussion about this. You have to first know that these are parallel. Okay, now does everybody understand that? We have to first know it's a parallelogram first, and then if 2 sides are consecutive, congruent, then we know for sure it's a rhombus. If you don't know it's a parallelogram, you can't say for sure it's a rhombus. Does that make sense for everybody? You have to know it's a parallelogram first. The second part, if the diagonals are perpendicular. What's it mean to be perpendicular? That means they have what type of angles? 90-degree angles. Okay, 90-degree angles, then they're perpendicular. And then if one diagonal bisects a pair of opposite angles. So what's it mean to bisect? It means to cut in half. So if it cuts in half, then it is then it's a rhombus. So a couple of special properties there. So special parallelograms, look in here. Determine whether the conclusion is valid. If not, tell what additional information is needed to make it valid. Number 1, EFGH is a rectangle. Can you say for sure EFGH is a rectangle? What do you say, Isabels? Yes, it is. How do you know, Isabels? I have a right angle here, and I also know that all of these sides are parallel. Does everybody see that? So that tells me for sure that is a rectangle. Now, number 2, this is the one that's kind of confused some students. MPQR, is that for sure a rhombus? Can we say for sure that is a rhombus? Tech, you say no. I agree. Why?
Because they're not on one dash.
Okay. I know they're congruent, but do I know that the sides are parallel at all? No. I have to know that these are parallel in order for it to be a rhombus. This is no. Alright? So recognize that. And somebody's like, well, it's very similar to the other one. Yes, but this one, they do not tell you it's a parallelogram first. You have to know it's a parallelogram. Okay? The next part here is we're going to talk about the diagonals and talking about the coordinate plane. You can identify special parallelograms in the coordinate plane by examining their diagonals. If the diagonals are congruent, what's it mean to be congruent? Same. How do you know? How do you find whether something is congruent, or how do you find whether the measures are the same in the coordinate plane? What are we finding? We're finding the starts with the D. What is it? Distance. Okay, when we're talking about congruency, we're talking about finding distance. Okay, that's something you have to remember. Anytime we talk about congruent, we always want to talk about distance in the coordinate plane. Perpendicular.
What?
How do we find out whether 2 diagonals are perpendicular?
Good.
So as I said, when I need to find perpendicular, I need to find the slopes. And then if it's congruent and perpendicular, that makes it a square. So really what we're going to do in the coordinate plane is we're going to find distance and we're going to find the slope. Can we all agree that is two things that we do quite often in here?
Yes.
Yes, it is.
Yeah. Bingo right there.
So we're going to find distance and slope.
You better watch yourself. I'm watching you.
In a shape like this. We got a shape here now in the coordinate plane. Okay. Recognize, because this is where some students were getting confused earlier. I have a rectangle ABCD. Recognize my diagonals are A and C. I'm looking at my diagonals here. So I do not go AB, I go AC. And then I use BD. I am not taking the coordinates next to each other. I'm kind of taking every other coordinate. Okay, understand that. So if I give you a list of 4 coordinates, you do, the first and the third and the second and the fourth. You don't do the first 2 and the second 2. That's going to mess it up.
Why?
Because that's where the diagonals are. They go opposite. Now if you look here, look at my distances. My distances are the same. My diagonals are the same, which means I have a rectangle. If you look at my slopes, are my slopes negative reciprocals? No. In order for it to be negative reciprocal, it would have to be negative 5/4. So it is not a rhombus. This is only a rectangle. Okay, so we're just going to follow those properties. So as I look at numbers 3 and 4 here, it says find the lengths and slopes of the diagonals to determine whether a parallelogram with the given vertices is a rectangle, a rhombus, or a square. Give all the names that apply. So I'm finding E and G, and then F and H. And I'm going to do the same with the next one. I'm going to find P and R, Q, and S. All right, can we find distance and slope? Can we all agree to find those things? Good. Find the distance and slope of all 4 of those right there and determine whether it be a rectangle, a square, or a rhombus.
Why do you erase that?
Oops. All right, so number 3 here, we had to find the distance first. What was the distance from E to G, Darian? It is square root of 26. What is the slope of E to G then, Nathan? Ooh, it is not. Negative 5/1? Right? Good. What's the distance from F to H? Distance from F to H, Suter? Square root of 26. What's the slope of F to H, Ezra? 1/5. So now we look at them. Are my distances the same? Yes. Are my slopes negative reciprocals? Yes. So they are congruent. They are perpendicular. I have a rhombus. And then look at number 4. PR. So I'm looking at PR. The distance from P to R is what, Tiana? What is it? It's square root of 2. It's okay. What's the slope of P to R? Slope of P to R? Slope is 1. And then the distance from Q to S. What's the distance from Q to S, Emily?
Q to S is 6. Negative 1 squared.
The distance.
Oh. 0?
Distance. Distance is... Ezra?
I'll give it that one.
It is square root of 18.
How? How? I had that too. Why did you say it?
That just seems so wrong.
It's square root of 18. And the slope of QS is then... The slope is negative 1.
Yeah, but how'd you get negative 18 if you had to do
Square root of 18?
3 squared and
3 squared?
negative 3 squared? So it's 9.
Okay. 3 squared. Squared makes it positive.
Plus 9.
Hey, look.
I bet my
So you get
blown up right now.
9 plus 9, which is 18 then.
You got
So now as I look at these here, are my distances the same? No. Are my slopes reciprocals, negative reciprocals?
Yes.
Yes. So this means I have...
Rectangle?
Oh, this top one. That wasn't a rhombus. That top one was a square.
Oh, I already wrote that really big.
Yeah, that's square. This one is a rhombus. Whew. Thank you. Yeah, this one is a rhombus. I know, I kind of messed that one up, didn't I?
Yeah.
Note to self: 3 square, not rhombus.
Did you just record us? Get our phones taken away?
Yeah. Nah, I push pause.
No, not
pause
for
it.
mine.
Oh, here's your assignment.
Assignment. We haven't finished going over the last.
Yes!
3-point assignment.
I did it!
3-point assignment right there.
Yes!
Oh my god.
I don't have to